Hi. Today, I'm going to do my video for the problem situation number 2 that we had to do. I did this individually actually, so I'm gonna just start explaining it briefly. So basically, we were given data sets of car sales for 3 years, and we had to decide of the 5 models that we were taught in class, which would be the best to use to forecast the next year, the car sales of the next year for a car agency. And basically, immediately right off the bat, I excluded the moving average method and the single exponential smoothing method, because the moving average method is it's only used when data is stationary and it doesn't have like an upward or a downward trend, when the data is just kind of flat and stays around the same value. And the single exponential smoothing method is used assuming that there isn't a trend, which means, so I was able to exclude those two right off the bat. That left us with 3: Brown, Holt, and the Winters method. So I ended up trying all of those. With the Brown's method, we got an MSE, a mean square error value of 10.01, and the forecasting values were 12, 12, 13, and 14 for the next year. So it was a pretty low MSE, but the forecasting values were kind of weird. It Unlike the original graph, it basically went straight up. It didn't have like a down for the first quarter of the next year, which is one of the problems with the Brown method, because it doesn't take into account well for seasonal trends. The next method I tried was the Holt method. It's a little bit better because it adjusts for trends better, but it ended up with the same problem. The forecast values were 12, 13, 14, and 15, and the MSE, the mean square error, was 9.5. So again, 9.5, very low MSE, which is a good thing, but the forecast values were not that good. The MSE is only a measure of accuracy in the error, and it didn't have a lot of error in the forecast, but the forecast for the next year didn't make sense with the Holt method or the Brown method. So I went to the Winters method, which takes into account seasonal trends. The MSE value was 32.8, which was much higher than the Brown's method and the Holt method, but the forecast values made a lot more sense. It was 8.5, 11, 14, and almost 19, which makes a lot more sense considering the original graph. I even included in my paper graphs of the original data plus the forecast for each method, and the Winters method looked the most accurate, the most in line with the patterns established in the original data set. And then at the end, I checked for autocorrelation in the errors, and there wasn't anything significant, which means no problem. And so overall, in the end, I chose the Winters method for the forecast for the next year for this car agency for the answer. And the estimates that the method gave me were 8.5, 11, 13.5, and 18.5, which makes a lot of sense considering the original data with an upward trend. It's an upward trend, but seasonal. It goes down at the beginning and the first quarter of every year. Each quarter it goes up. The same. So like the original data was like this, and then with the Winters method, it had the same pattern. It went down in the first quarter, and it went all the way back up, reached a new high by the fourth quarter of the next year. Yeah, so I'm at 4 minutes now. My individual question was, do I think the moving average method was good for this? Like I already said, no, because the moving average method is only good for stationary data. It's not good for like trends, and so I didn't even include it in my paper. So no, I do not think that moving averages is a good method. Yeah, that's all I have to say. Thank you.